With the combination of the nonce value and the difficulty, we've implemented a proof of work system where miners must spend a bit of computational power to add blocks to the chain. However, as new miners continue to join the network, there will start to be more contributors attempting to discover valid hashes. New blocks will start being added at a quicker pace, as there are more chances for an individual to discover a valid hash earlier on in their attempts. Eventually, there could be so many miners that valid block hashes are discovered so quickly that the incoming data would spam the entire blockchain network. So this isn't ideal. We'd like blocks to be added at a more reasonable and controlled pace. Therefore, we'll introduce a dynamic system that adjusts the blockchain's difficulty level in order to bring the average rate of blocks being added, mined, closer to a set mining rate. To achieve this, we already have the difficulty attribute for each block. In addition to this, we'll also introduce a global time value called the mine rate, which represents the rate at which we want blocks to be added to the chain. Overall, the difficulty adjustment system is going to work like this. Alright, a new block is being mined, so we need to check its timestamp. We're then going to compare its timestamp with the last block. We're looking for the difference between the two timestamps. Now, if that difference between both timestamps is lower than our mine rate, then we know that the block was mined too quickly. Therefore, we'll raise the difficulty for the next block by 1. On the other hand, if the difference of timestamps between our newest block and the last block is actually larger than our mine rate, we know that the block was mined too slowly. Therefore, we'll lower the difficulty by 1. With this system, we'll always adjust the difficulty for each new block. On average, the time it will take for each new block to be mined will start to adjust around the set mine rate. The difficulty will raise if blocks are being added too quickly. Likewise, the difficulty will lower if blocks are being added too slowly. Okay, let's implement this system in our code. First up, in the config.js file, let's add a new global mine rate value. So in config.js, before initial difficulty, let's set a global mine rate value, and let's make this a mine rate of 1,000, which is 1 second because this mine rate is set in milliseconds. So 1,000 milliseconds is 1 second. Likewise, we should share this mine rate with other files by including it within the exported object at the end of the config.js file. Cool. So now let's actually use this mine rate to enforce a dynamic adjustment difficulty system. In the block.test.js file, let's also include the mine rate within one of the tests. So let's grab the mine rate from the config file. Let's add a new section to the test, which checks a new adjust difficulty function. So after the group of mine block tests, let's add a group for a new function called adjust difficulty. Nice. And then we have the callback as usual. First, we're going to check that the function raises the difficulty for a quickly mined block. We'll say it raises the difficulty for a quickly mined block. Then there's the opposite test case to cover, which check that it lowers the difficulty for a slowly mined block. So feel free to copy and paste that existing it test. And then this one should say it lowers the difficulty for a slowly mined block. So this difficulty adjustment function doesn't really need to be based on a specific instance of the block. So we can use it in the static context. So within our raise difficulty test, let's expect that if we call the static block.adjustDifficulty function, that this difficulty is going to be raised. And we're going to base this off of an original block. So within the adjustDifficulty function, we're going to provide an original block field within an object. And luckily, we already have a block in the test, so let's use this block instance over here. Now, another field for this adjust difficulty part is going to be the timestamp of the block to check. So when we adjust the difficulty, we're also going to have a field for the timestamp So that way it can figure out whether or not to raise or lower the difficulty of the block depending on that timestamp. In terms of this case, we want a quickly mined block. So let's use the original block.timestamp. We'll add the mine rate to this timestamp, but then we'll lower how quickly that block was mined by 100 milliseconds. So essentially, this adjust difficulty function is calculating a difficulty value based off the block and a block timestamp, and is checking whether that new timestamp has fallen greater than or lower than the mine rate. And in this case, it's lower than that mine rate because we're subtracting 100 milliseconds. And the result that we should expect this to equal is that original block difficulty, and since it's raised, +1. So overall, again, to review how this adjust difficulty function is working, it's taking an original block, and then it's taking a timestamp that represents a timestamp of a new block. And it's checking if that new block's timestamp falls within that original block's timestamp plus the mine rate, and we're seeing whether or not it's below or higher. And based off of that, it's going to raise or lower. All right, cool. So this allows us to make a similar check for when we want to lower the difficulty for a slowly mined block. Likewise, we'll call block.adjustDifficulty in the static context. It's still going to be the block as the original block. The timestamp is going to be the block.timestamp plus the mine rate. And then this time we're going to add 100 milliseconds. So it's going to fall greater than our mine rate threshold. And this should equal the original block difficulty lowered. So we're going to expect this to equal block.difficulty -1. All right, great. So notice that we're going to be doing arithmetic off of this timestamp. So in order for these tests to work properly, up at the top, for the timestamp value, let's actually provide a valid millisecond value. So let's provide 2000 as a millisecond value for all following tests. Now go ahead and save this and then run the test suite. You might already have it running in the background, in which case you'll see the 2 failing tests for our new adjust difficulty scope. So right now, adjust difficulty is not a function, but let's go ahead and fix that right now. So within block.js, we're going to add a new static function called adjust difficulty. The input to this is an object that consists of an original block and a timestamp. And we need to return a proper value to get these tests to pass. And it's all going to be based on the difficulty of the existing block. So first, let's destruct the difficulty from the original block. And by default, let's return difficulty +1. So that will be the default behavior of adjust difficulty. And as we save this, cool, that covers a case where the difficulty should be raised. However, we still need to cover the case where the difficulty should be lowered. And to do that, we need to check that this new timestamp comes within the mine rate value according to this original block's timestamp. So at the top, let's also require the mine rate from the config file. So have that next to Genesis data. And then once you have that, head back to the new adjust difficulty function. And then let's get a value for the difference between the incoming timestamp and the original timestamp. So let's make a const of difference. This will be equal to the timestamp minus the original block.timestamp here. Cool. And if this difference happens to be greater than our set mine rate, so if it's greater than the mine rate, well, instead we want to return difficulty -1. Because if that difference is greater than the mine rate, well, then the block was mined too slowly. Therefore, the difficulty should be lowered. Cool. Now, as we save this, all the tests are now passing. Very nice. Now, notice that this difference constant is only used once, so we can actually inline the second part of the statement right here where difference is used. Make sure to have a pair of parentheses around here. And this will make our overall code for the adjust difficulty function a little more clean. All right, great. Next up, let's make sure that each new block's difficulty gets adjusted by incorporating the adjust difficulty functionality while a new block is being mined.